This is lesson 11.3, the law of sines and cosines. In this lesson, we're going to learn to determine when to use the law of sines or the law of cosines in order to find the missing measurements of triangles. All right, so let's talk about different situations that you have in triangles and how to know which of the laws to use. All right, so let's say you have a triangle like this. So we're given angle, angle, side, right? So you can see that we have two adjacent angles and then a side next to them. You probably remember these abbreviations. All right, so which one works, right? So let's say we wanted to find side little r, right? So to find side little r. So you want to look at this and say, do I have stuff across from each other? So I do. I have the 25 degrees across from the 9, and I have 28 across from the r. So this is law of sines. I prefer to use law of sines. Law of sines is the less complicated one, so I try to use the law of sines whenever possible and only use cosines if I have to, right? So if you have this kind of situation and you're solving a triangle, and then this kind of triangle is also nice too because you know two of the angles. Anytime you know two of the angles, you can find the missing angle by subtracting from 180, right? And then again, if we want to find side little s, we can use the law of sines again because we know the angle across from s by subtracting from 180. All right, so what if we have angle, side, angle? So the two angles with the side in between them, like this. So this one, if you wanted to use law of sines, we'd have to know an angle across from 28, which they haven't given us, but if we want to find that angle, you can use the 180 method, right? Anytime you know two of the three angles on the triangle, it's nice because you can just find that angle easily. And then we'll be able to use the law of sines if we want to solve for either r or q. We can now solve them using the law of sines because we know all the angles across, right? So that's nice. All right, what if we have the case of two sides and an angle, and in this one, it's one of the angles is across from one of the sides. So this one, since you have an angle across from a side, we can set up law of sines, and the side we have is across from r, so we're going to set up law of sines in order to solve for the angle this time first. And then after we've solved for the angle, we can find the other angle using the 180 method, right, using our r that we found. And then finally we can solve for the last side little t also using law of sines. I always try to use law of sines first, right? Okay. So next we have two cases, side angle side and side side side, and these are where you have to use law of cosine. So side angle side or side side side. And these ones, law of sines won't work because you don't have anything across from anything else, right? So I have this angle 130, but I don't have the measurement across from it. And I have the 29 inches, but I don't have the angle across from that. And I have 25 inches, but I don't have the angle across from that. So this is where we have to use law of cosines instead. So when you have this situation, you have to first solve for the angle across from, or the side. You have to solve for the side across from the angle that you know, right? Because that's how you set up law of cosines. Little a squared, and then cosine of a will be on the end. After you've solved for that, then you can switch to law of sines, right? So you could solve for angle B or angle C. You can switch to law of sines now because you'll know little a across from big angle A, which allows you to set up law of sines. And then you can solve for the other one that you didn't solve for using the 180 minus 130 minus the one that you solved for, right? All right, and then finally, side, side, side. This one, obviously, you can't use law of sines either because you don't know any angles at all. So you don't have any angles across from any sides. So this one, you can pick any of the angles. You could pick P or H or K, whichever one you want to solve for, and set it up with the law of cosines. Just remember, if you're solving for p, you're going to make it start with p squared equals. If you're solving for h, you're going to make it little h squared equals. If you're trying to solve for k, you set it up little k squared equals, right? So law of cosines. And then after you've done that, you've got one angle. Once you have one angle, you can switch to law of sines. So you can solve for another angle with the law of sines. And then finally, you can solve for the last angle using the 180, right? Minus the two angles. So angle 1 minus angle 2, right? Whichever one you chose. Okay, and this is important. Don't forget to use the fact that the angles in the triangle add to 180, right? It takes one less step if you remember that. Okay, so let's try it now. So let's look at what we've got. So I see that I have a side, an angle, and a side. Now I don't really memorize which kind of triangle to use in which situation. I look at it, right? I always try to use law of sines if possible, but I say, oh darn it, in this situation I don't have anything that I know across from a value. I don't know this side across from 78. I don't know this angle across from 22. I don't know this angle across from 24. So this one must be a cosines because we don't know, right? So this one, whichever angle you have, is the side you want to start with, right? You need that. So remember law of cosines, so we do b squared, and then we use the other two sides. It looks a lot like Pythagorean theorem, right? Minus 2, now use those same two sides, and then cosine of our angle. So we're going to type all of that in the calculator. So I won't show you this time like we did last time. I'm just going to type it in my own calculator. You could try typing it into yours. So I'm going to type it in mine. Make sure that you're in degree mode for all of this, right? So I typed it in and I got 840.445, right? And then remember, this is b squared. So now to solve for b, we have to square root this answer. So I'm going to square root it, and I get that b equals 28.99. If we're supposed to round, that would round to 29.0. Okay, the next thing we have to solve for, we have to know angle A, and we have to know angle C, right? All right, so I use law of cosines. Now I can switch to law of sines because we just solved for that 29.0 across from our 78, right? Now we can pick either A of C. Let's pick A. So angle A is across from a side that's 24. Okay, cross multiply. 24 sine 78 equals 29 sine of A. And then we can divide off the 29. The A is stuck inside the sine. Remember this? Okay, so in my calculator, I'll type 24 sine of 78 divided by 29, right? And so I get this 0.8095, right? 0.8095. Oh my goodness, I just wrote it totally backwards. Sorry, guys. 0.8095. And remember that that's the sine of A. So to get A out from this sign, we're going to use the sine inverse. 8095. Okay, so I'm going to type in my calculator the function key sine inverse of the answer, and I get 54.04. So if we round it, 54.0. And then finally, angle C, here's where we get a bit of a shortcut, right? You don't need to use law of sines or law of cosines, just use the fact that the three angles have to add to 180. So if I take 180, subtract off the 78 that we know, and the 54 that we just solved for, right? Then we get 48. Okay, so there's my three missing pieces. Little b, angle A, and angle C. Next one, find the length of RT. So RT, that's little s basically. All right, so let's look at what we've been given. Do we have anything across from S that can help us? We don't. So that's not nice. We don't know angle S. Okay, but I do know angle R across from side R, right? And so this is one where I'm going to have to do a couple of steps. Like sometimes you have to solve for other things besides what you want in order to get to what you want, like multiple steps. So I could set up law of sines with this 66 and 28 and solve for angle T if I wanted to. And then once I know angle T, I can subtract that from 180 to get angle S. And once I know angle S, then I can use either law of sines or cosines, since it's across from little s, to be able to solve for s. So in essence, we end up having to solve the whole triangle anyway, because RT is the last thing we're able to get. So let's set this up. Sine of 66 over 28 equals sine of t over 18, right? So cross multiply. 18 sine 66 equals 28 sine of t. Divide off the 28, and then the t is stuck inside the sine, so we're going to have to do the sine inverse of what we get here, right? So we'll type that in, and I get 0.587 for 18 sine 66 over 28. And then if I take the sine inverse of that function, sine inverse, then I get 35.9, so 36 degrees. Okay, so that's angle T. Now I can say the whole triangle has to add to 180. So I'll subtract off that 36 and 66 and get 78. Okay, and now I can finally solve for little s. So sine of the angle we just found, s, over our unknown side s, equal to sine of 66 over 28. Okay, cross multiply. And then s times the sine of 66. So this time we can divide off the sine of 66 to get s by itself. Right, that will cancel and we're left with s. So we can type that in the calculator. Okay, and we get 29.9. So if we round 29.98, it rounds up to 30. Okay, so sometimes you're going to have to do multiple steps, which is kind of sad, but you know, it's math. We never said it was easy. All right, so let's try this one. We're using the law of sines to solve the triangle. So you can see that this one is a law of sines problem because you have an angle 65 degrees that's across from a side 28, right? So we can use the other angle and solve for little side f. So let's set this up. So sine of 65 over 28 equals sine of 54 over f. And now we can cross multiply. So 28 sine 54 equals f sine 65, and then divide off the sine 65 to get the f by itself. Oh look, I forgot an s. Okay, so now we can type this in our calculator and get the answer for f. Okay, so we type it in and I get 24.99, so we'll round up to 25. Okay. So that's the first part, but remember, solve the triangle means solve for all missing pieces, so we also need to figure out what angle D is, and we also need side little d, right? So angle D, that'll be pretty easy because we know two angles already, so I can just do 180 minus 54 minus 65, and type that in, and I get 61 degrees for my angle D. Okay, and then finally, little d. Now that we know the angle for big D, we can set up law of sines again with the big D angle over our unknown little d side. And then we can use the sine 65 over 28 again. So 28 sine 61 equals d times the sine of 65, and then divide off the sine of 65. Okay, so we type that in the calculator and we get 27.02, so 27.0 feet. Okay, so we've solved for the whole triangle, all the missing pieces. So next one, use the law of cosines. I can tell I need to use the law of cosines. I have side, angle, side here. Side, angle, side, so I don't have anything across, right? I don't have angles and sides that are known across from each other in order to use law of sines. So remember, when you're using law of cosines, you need to start with whatever angle you've been given and the side across from it. Okay, so I'm going to do c squared equals little b squared plus little a squared, right? Just like Pythagorean theorem at first, minus 2 times those same sides times the cosine of the angle in between it. Now I have to type all of that into the calculator, and I get 783.07, so we'll round to 783.1. And of course, square root this now. Remember that that is c squared, so I have to square root my answer, and I get that c equals 27.98, so we'll round up to 28. And don't forget your units. If there's units in the problem, you need units in your answer. All right, now that we've got the side, we now have a side across from an angle, so we can switch to law of sines, which is easier to use. So sine 76 over the 28 that we just solved for. Now you could pick either A or B here. It doesn't matter the order that you do it in. So let's say we pick A. If we pick A, then we need to use side little a across from it. So 20 sine 76 equals 28 sine A. And A is stuck there in the sine, so we just have to divide off the 28, and then we'll need to use the sine inverse to get the A out of the sine. Right? So let's type that in the calculator. Okay, and I get 0.693, so I'll do the sine inverse of that in the calculator, and I get 43.9, so we'll round up to 44 degrees. Okay, so now we have, that was angle A. The only part we're missing now is angle B. Since we now know 2 of the 3 angles, we can just do 180 minus the 2 angles that we know, right? So we'll type that in the calculator, and we get 60 degrees. And that's our missing angle B. And we have solved the triangle. Next one, solve the triangle by any method. So we need to look at it and decide what information we have. So I always look to see, do I have a known angle across from a known side? I do. So I can use law of sines. So I have sine of 97 over 29. I know both of those. Now the other thing I have is the side 26, and that's across from angle K. So cross multiply 26 sine 97 equals 29 sine of K. The K is stuck inside the sine, so we can divide off the 29, and then we'll have to use the sine inverse. So we're going to type in this 26 sine 97 over 29. Okay, and I get 0.8898, right? It goes on. So we're going to do the sine inverse of that. So in my calculator, I'll do the function key sine inverse of the answer, and I get 62.85, so 62.9 degrees. Okay, so there's our first thing that we were missing, right? You can list the things that you're missing right here if you want to help you keep track. So we got K, right? We're still missing angle P and side little p. So angle P will be easy to get because now we know 2 of the 3 angles. So just subtract from 180. So I'll type in my calculator 180 minus 97 minus 62.9, and I get 20.1. Okay, and finally we need little p. So little p, we now know the angle across from little p. We just barely found it, so we can set up law of sines with our new angle that we just found over our missing little p. And then let's go ahead and use sine 97 over 29 again. So 29 sine 20.1 equals P sine 97. So this time the P is not inside the sine, so we can divide off the whole sine 97, and that will give us P. So I'll type that in the calculator, and I get 10.06, so 10.1. And of course they gave us units, so we put in units. Okay, make sure that your answers make sense. The biggest angle should be across from the biggest side, smallest angle across from the smallest side, and that does make sense in this problem. All right, last problem. Triangle LMN has sides. LM is 30, MN 28, LN 25. So let's draw a picture. Okay, LMN. So LM is 30. MN is 28 and LN is 25. So what we're missing is the three angles, right? So we need to find the three angles. Okay, if you're missing an angle, you can't use law of sines. We have to use law of cosines. So we have all three sides, so it doesn't matter which one we pick. So let's start with L. If I want to start with L, I have to start with the side across from L. Okay, so 28 squared equals 25 squared plus 30 squared, just like Pythagorean theorem to start. Minus 2 times 25 times 30 times the cosine of the angle that was across from where we started, right? If you start here, you end with the angle across from it. Okay, so this is the one where we have to solve for L, but L is trapped inside the cosine, so we got to get rid of everything ahead of the cosine. So this is where we can subtract off the 25 squared and subtract off the 30 squared. And remember, all of this is being multiplied by the cosine of L. So we have to divide this by -2 times 25 times 30 to solve. And then we'll have to do the cosine inverse in order to get L out of the cosine. Okay, so I'm going to type all of this in my calculator and see what we get. Okay, so I type it in and I get 0.494, and now we have to do the cosine inverse of that. So we go into functions, cosine inverse, pop in the answer, and I get 60.39 degrees, so 60.4 degrees. All right, now we have that angle that we just solved across from a side, so we can switch to law of sines. So sine of the angle we just found over the side 28 across from it. Now we can pick either one. We could solve for n or we can solve for m. Let's solve for m. We'll just go in alphabetical order here. So if we're going to solve for m, we need to use the side across from it, 25. So 25 sine 60.4 equals 28 sine m. So once again, m is stuck inside the sine. We can get rid of the 28. And then we're going to have to do the sine inverse, right? So let's type in 25 sine 60.4 over 28 in the calculator. Okay, so I type that in and I get 0.776. And then we do the sine inverse of that to find the actual angle value, and I get 50.92, so 50.9 degrees. Now the last angle is the easiest, because we just have to subtract these from 180 to find the final piece, right? So I can type in 180 minus 60.4 minus 50.9, and I get 68.7. And we're done. All right, so try your homework and make sure that you send questions through email or Remind or on the office hours if you have questions. And thanks, guys.